In this question, it is given that let S be the set of all complex numbers Z satisfying this inequation. If the complex number Z0 is such that 1 upon mod of Z0 minus 1 is the maximum of the set this, then the principal argument of this is you have to find the correct choice. First thing is you should know that when I'm writing this symbol, it means I'm saying about general argument. But if I say about this, it means I'm saying about principal argument. This is the notation used for general argument. This is the notation used for principal argument. That is, the difference lies in capital A and small a. First thing is, let us find the set S, that is all the complex numbers which satisfy this inequation. Now this can be written as mod of Z minus 2 minus I greater than equal to root 5. This clearly means the distance of Z from 2 minus I is greater than equal to root 5. First of all, I draw the graph of Z minus 2 minus I equal to root 5. Two minus 1 is somewhere here. Distance from origin is clearly root 5, and therefore this equation represents a circle with center 2 minus 1 and radius root 5. But actually it is given that Z minus this thing is greater than equal to root 5. Hence I can say all those complex numbers which satisfy this inequation will lie outside the boundary of this circle. And then he says Z0 is a complex number for which this is maximum of the set this. Means Z0 is that complex number of the set S for which this is maximum. Or I can say Z0 is that complex number of the set S for which is minimum. One is somewhere here. Out of all the complex numbers lying outside the circle, the complex number whose distance from 1 0 is minimum, that complex number will be named as Z0. Out of all these complex numbers, to find the complex number which is at minimum distance from the point 1 0, to find that point, remember the concept that suppose some curve is given and some point is given, and we have to find a point on the curve which is nearest to the point P. Remember that find the point on this curve whose normal passes to the point P. The point whose normal passes to the point P is sure that that point will be either at minimum distance from the point P or at maximum distance from the point P. That is, on this curve, find all those points whose normal is passing to the point P. The point of this curve which is nearest to this or which is farthest from it will be one of these points. Therefore, out of all these points, the point which is nearest to the point 1 0, the normal at that point will be passing to the point 1 0. And we know that the normal at any point of the circle always passes to the center of the circle. Hence, required point is that point where the line joining center and the point 1 0 intersect the circle. And it is obvious that the x coordinate of this point will be surely less than 1, and y coordinate of this point is sure to be a positive number. That is, if this is the point z0, value of z0 is alpha plus beta I can surely say that alpha is less than 1 because the x coordinate of this point is 1, and beta is sure to be greater than 0. Argument of 4 minus z0 plus z0 bar upon z0 minus z0 bar plus 2I becomes equal to argument of 4 minus 2 alpha upon 2 beta I plus 2I. That is, this is equal to argument of 2 minus alpha upon beta plus 1 into 1 upon I, and 1 upon I is minus I. That is, I get argument of 2 minus alpha upon beta plus 1 into minus I. Now it is clear that this being a positive number, hence I can say this is a purely imaginary number with imaginary part negative. Hence the argument of this will become minus pi by 2. Hence I can say C is the correct choice.